I'm going to make a simple LiPo battery charger. So we made the drone finished up last week, but then we didn't make a battery charger. So today I'm just gonna make a simple single cell battery charger. So let's go KiCad. So file, new project, like I mentioned. So you've got project templates, alright? So here's actually quite cool where we can have expansion boards. So if I want to make a PCB that I can fit directly in my Raspberry Pi or my Uno or my Mega, I just click on it and I will have a board that I can just click into it or connect to it, should I say. So I can put my components here, make connections, and I'll be able to take this and put it straight onto my Arduino. It's pretty cool. That's not what we're going to do today. So we're going to start a new project. So we're going to do battery charger LiPo. Great, so we've got our schematic. You'll see at the bottom my battery charger, hardware revision, the date, and then who did it. That's very nice just to keep track of everything. So what we're going to do today is make you know the batteries you normally buy at the hobby shop. I wonder if I can find. So a lot of times when you have a project, you'll have a battery like this that you buy to power your project while you're busy with, when you can't have it plugged into a wall or a USB. So we're going to build a single cell battery charging circuit and a PCB that we can plug this battery in, plug in a USB, and it will smart charge it. So that's the goal of today. I think most people are aware of these type of batteries. They actually come with a smart circuit inside of them. As you can see, that small strip there is actually a circuit of its own to protect it from short circuits, from under voltage. So when you have a LiPo battery and you don't want to make it empty, totally empty, because then you can't recover it. So this makes sure that when it's just too low, it'll switch off to protect it. So let's get started. So you have this goal now to charge your battery, but that goal will need some components to make that goal happen. So we're going to look for a chip or IC that will make life easier for us, so the brain behind the project. So I'm going to use the MCP, so it's a microchip. So the MCP 73831 is just, so a LiPo battery says 3.7, but fully charged is actually 4.2. So we're going to use this to charge our battery. So you can see that it's got LED to tell you if it's charged, all the fun stuff. So we can view the data sheet. Don't worry too much about the detail, but as you can see, most data sheets will tell you how to make the circuit. So there you go. So they tell you connect your battery like that. Maybe have some of these capacitors. These are called decoupling capacitors. I'll explain more later on. You need a resistor for the LED. So this is your status LED. Your status LED is just going to say, is your battery charging or is it fully charged? So when this is fully charged, this chip is smart enough to say, I'm full, I don't need to charge anymore. And this is the program resistor. This resistor will just control the current to the battery. So how fast you want to charge the battery. So playing with this can make a big effect on how quickly your battery charges. This place name is quite important in schematic design. So you place things onto the schematic. So as you place symbol, board, wire, bus. These are most of the stuff we're going to use. So I just want to put an image because I want to put the schematic there. So there you guys can see. So I put this picture in my schematic so that I can have it when I design. So we've got this. So like I said, place is very important. So we can either push, so we've got this. So like I said, we want to place a component. So this MCP 373831 is known as a component. In your schematic, it's a symbol. So all these pictures are symbols. So I want to place a symbol on my schematic. Place symbol. So I can either go place symbol, or on my keyboard, I can just push A, and then all my symbol libraries will come up. Great, so you can see here all my components in the KiCad libraries. So these are all default. So you can go on the internet, I'll speak about that later in maybe another video. You can go on the internet and download libraries from DigiKey and all those places. So you hardly ever need to make your own symbols, components, but you can, and we will. Not today, but we will. I think there's a video that Kerry did on YouTube about creating your own symbol. So you can see all the components we have, just different drivers, different LEDs, all that stuff. So this is all inside the KiCad libraries by default. You see oscillators. See Plumpot, we made a component before. So you won't have that in yours when you download KiCad. So let's see if they've got this MCP73831 in their own library. There we go. So they actually do. So you can see there, you just take the number, that's called the MPN, that's called your manufacturing part number. So every component in the world has a number that is linked to that component. So there we go. So you can see this. So SparkFun as a company, I think you guys know, they also have a library that we installed. I can send you guys the links if you want the library, but you can see there. So just be careful. The chip's MPN might be exactly the same, but there's sometimes numbers at the end of the chip that changes it a bit. So the family might be the same, but you can see here there's 2, 3, 4, 5 OT. So that is just the output voltage. The 234 is the output voltage that you can choose of the chip. So it's 4.2, 4.35. Because LiPos, you can charge a bit over to 4.35 if you want as well. I think the life of the battery might decrease a bit, but I'm not too sure. But we're going to use the 4.2 volts one. I know it's safe. There we go. So there's our component. So you can see we've got the VBAT, same as the datasheet. We've got the VDD, same as the datasheet. Stat, VSS. It's very important to make sure that the component that you have in KiCad, that the pinning numbers are the same as your datasheet. So you can see pin 2 here is VSS, pin 2 here is VSS. That's very important. Stat is 1, VDD is 4, VBAT is 3. So this and this correlates to one another. So VDD is my power. So first, what I first do is I think about how the circuit, what do I need to charge my battery? I've got this chip. How am I going to input my power and how am I going to charge my battery? So for the input, I'm going to use a USB, micro B. And then for the output, I need to have a connector, like a JST connector or something. We'll get there. Hey Ranish, how you doing? So if we push A again for components, and I type in micro USB. So this USB, I'm not gonna use it for programming anything. So you can see D plus D minus, so that is the communication lines. We're not gonna use it for that, we're only gonna use it for charging. So we're only gonna use the power, V bus and ground. So now we've got our input. We've got the IC that's gonna process the input, and then we need an output. So designs you do on a PCB is always going to be some input, some processing you do, and some output. That's just electronics engineering. That's basically what you do when you design something. Are you 21 now? How old are you? 21, still young. So we're going to look for a connector. Guys, please, any questions, just shout, eh? If I'm going too fast, if I'm losing some of you. So I want my connector to show that way. So I'm gonna push X for flip. So X, you can see, flips it, and then R for rotate. So now we get to the next step of the schematic is called the wires. So the wires are a way of connecting signals or components to each other. So if I push W for wire, you can see something pops up. So I'll go V bus, wire. No, that's a wire. So I need that, and I need my ground. So we need to give this V bus power, should I say. It's called a power source or a power port. So I'm going to say place power port, and you'll see I'll get a bunch of different ones. So for this, I'm going to say V bus There we go. So V-bus is just a terminology used for USB power. I'm going to put this here next to it. So you can see Vn is the voltage that's going to charge my battery, and we are going to charge it with this USB micro, and this is the power. So this is actually output, right? So the USB gets plugged in and it supplies 5 volts to this V-bus line. So I'm going to take this, if I copy it and I paste it here, it needs to be connected to my VDD, right? Because that's what it is. Vn is connected to VDD. Because these names are the same, that means they are connected in real life. So it means that even if I took a wire like this all the way there, it's the same. So it's just the easier way to make sure the wires don't go all over the place, so you can connect it by names. You can see VSS is ground. I'll show you guys, because this might actually look a bit different than this one because of how my pins are. So in a schematic, you can see these small triangles, they are grounds. So mine looks a bit, mine looks the same. But sometimes I don't have to have it. So this here, this is what I push, place port power. Guys, if you can't see what I'm pushing and something's hiding it, please let me know. But you can say place power port. So sometimes the ground can look like that in schematics with the 3 lines or this triangle. So we've got that. So then my VDD goes, my Vin goes to VDD, pin 4. It goes to LED with a resistor to my status. So let's push A for symbols. Yeah, I can hide the chat, but then if people on Twitch chat, then they can't see it, or you guys can't see what they say. But you guys can see what each other says on YouTube, right? Yeah, make the screen bigger. Yeah, we're restreaming on Twitch and YouTube. So we need a resistor and an LED. The direction of the LED is very important, so it goes down to ground. So you guys actually read it on YouTube itself, should I say? Okay, yeah. If someone chats on Twitch, I'll just read it out. Anyway, if you guys can't read it, it doesn't really matter. To move stuff, you just push M to move. So I've got my voltage that goes to an LED, and it goes to VDD. So I've got a voltage, goes to LED and to VDD. Then we've got a resistor. And then push W for wire, and then goes to my stat. So you can see here they say 2 kilo ohm. 2 kilo ohm. So to do that, you just click on it, double click on it, and then your properties will come up. And there you can see value is 2K. So we just call it 2K. We'll get to the footprints later. Let's connect this. Shortly we're going to make it 0603, but we'll get there later. So I'm first going to, no, 0805 is too big. Hey Ashad, Pushali, I'm first going to make the schematic and then I'll add the footprints. I'm going to do this just to neaten up. So it's exactly the same. Let's say it's the same. I'll put it this side. So my VSS is going to be my ground. So I'll take this ground, copy it. They have the same name, so they are one. Oh shucks, this was supposed to go to stat. We missed it. No, 2K is fast enough. I've got 2K I actually have 2K2 on my designs. We can look at the diagram later. Let's just stick to basics. So I've got my VBAT. Now I need another source for my battery. So I'm going to call this VBAT. So this and this are both power supplies, but they are not the same. Different names, different singles. Okay, so I've got my battery. Now we need to program the speed of the charging. Copy this resistor. And this is, you see, this is wrong. So that resistor is to restrict the current for this LED. And this is way too high. The LED will be very, very not bright. I'm getting confused with the resistors. I think that's what you meant, right, Nish? Not the charging of the battery, but the LED won't be very bright. This must be 2K. No man, you guys have beards. I've seen a lot of Indian cricketers with beards. So this will charge the battery, the program resistor, will control the speed of the charge. Oh, no, the Netherlands is not like that. So now we're just missing these capacitors. So this is just a preference. You can put the capacitors like that in line, but I like to keep them separate. Just a preference, it's just nothing more than that. And then I'm going to put V in, which is my V bus. To ground. So it's exactly the same. So these are just decoupling capacitors to make sure my supply in is smooth. And then I need the same for the output. So I can highlight everything, copy, paste. But now this becomes VBAT. Highlight, delete, click on it, push C, and then we go. So that is the same as this. I hope that makes sense. So now we basically drew the same circuit as this. I don't think we're missing anything more. We've got our USB power coming in. It has decoupling capacitors. So decoupling capacitors just to make sure that my supply in is stable so it doesn't ripple. V-bus goes to my LED. I've got my 470 ohm resistor to limit the current for the LED, and then status, which will tell me what's the status of my battery. Great, so I have my VBAT. My VBAT's the single layer cell. So that's it. So we just made a first circuit according to datasheet. How easy was that? Our battery will be connected like this. So the battery connector always has 2 pins. You guys are too quiet. Am I losing you? You guys are you with me? Yeah, Ashad, you know all this stuff, eh? How's your projects going? How's your tokens, what do you call it, badges? You guys always talk. I like it, I like it. I'm fine. Cheer him up. I just don't want to go too fast, and I'm lose people that want to learn. So please, guys, I'm going too fast. Just stop me. Who did you use? JL or PCB or the place in India that you told me about? OTA? What's OTA? OTA. So now I'm just going to neaten it up a bit. For this project, I think I'm going to make this page smaller. So page settings, A4. Okay, there we go. That's better. Oh. Oh, that'll be amazing. When isn't that's not already released? So what I'm going to do now is just put it, I like to put my designs in little boxes. So when I see the future, so at the bottom right here, I can make a box. Don't push escape too early. There we go, so I can place a text. So micro USB to supply charge. Always save, guys. Don't do what I do. Always save. Who did you send your PCBs to, Ashad? And then I'm going to do the same here. So yeah, I'm going to say MCP 73831 battery charging circuit. Why are you typing in capitals all of a sudden, Anish? You're shouting at poor Ashad. There we go. So that's my circuit's charge. Yeah, it's frowned upon by some people. Maybe he's angry with you, Ashad. I don't know what you did. Maybe he's very upset with you. Battery connector. So we've got our input. Click and push C, you can copy it. Great. So like I said earlier, in electronics and when you design, you always have inputs. You do something with the input and you have the output. That's the basics of any design. So that's the way you must start thinking. So I've got something I want to do, what I need to put in, what I need to process all the information to get that result that I want. So what I wanted is I want my battery charged. How I'm going to do it? I need something to charge it with, my input, and I need some smart circuit, to charge the battery. So that is what we have now currently, right? So we've got our input, our process, and output. And I actually think that's all we need to charge a battery. So now you see that there's a lot of question marks here. J0, C, D. They are called designators. So they're called designators, and they represent the components. So for connectors, you'll have J. For ICs, you'll have U. For capacitors, C. Resistors R. LEDs, D. Connectors, J. So for that is basically, you'll see when you get to the PCB, they'll have also designators. So my PCB will have D1, and my schematic will have D1, and that's how they link to, that's how they know where they are with respect to one another. So we don't type in every single one, so we don't go there, C1. On top left here, you'll have tools, annotate schematic, and say annotate. You'll see all of them updated. Perfect, eh? J1, C1, D1, R1, R2. So it will always annotate from left to right. So you'll see J1 here, and if we have another connector on the right, it'll be J2. I've got C1, C2. So always left to right. You can change it, but it's not important.